We have data that tells us what a chemist observed from a 100-gram sample of radioactive material, telling us the weight at each week from the observation. And we want to build an exponential model for this data. Okay, so we need to put the data into the calculator. The key button here is Stat. So at first I'm going to clear off what's in my lists. So I'm going to clear list. Then I have to tell it which list, so second, and then 1, above it says L1. I'll clear that list, and then I'm also going to clear L2. Okay, now to put the info in, stat, edit. Alright, so I'm going to put my weeks in my L1, so that's just 0 through 6. Okay, just hit the value and then hit enter after each one. And then now for my weight. So let's see here. I need, make sure they're lined up. So across from 0, I need the 100.0. And then 88.3, 75.9, 69.4, 51.8, and 45.5. And let's see, oops, I must have missed one because I don't line up here. 88.3. 75.9, 69.4, 59.1, I forgot. 51.8 and 45.5. Okay, so now I see that my data lines up, so that's good. Now I've already been told to do an exponential model, so I don't have to look at the graph. But remember, if you do want to look at the graph, if you go to second stat plot for the y equal, just choose one, turn the plot on. This type of data point is fine. You have to tell the calculator where your lists are. And then on your window, you need to make sure that you're going to see your data. So 0 to 10 is fine for the x's, because that's where I have the L1s. And my y's need to go up to at least 100. So let's go 0 to 100. And that's how I see my scatter plot. Now I can change what I have here. Let's see, so my window, I could start that at 0 for the x's. That gives me a little bit. Now, if I were just going to pick on my own, I might even say that this is going to be linear, but I've been told to do an exponential model. We have very limited data points here, and that's so that it's more convenient for you to put it into the calculator. With more data points, we should be seeing more of an exponential graph. Okay, but we're told to do exponential, so that's what we're going to do. Okay, so I'm going to go to my stat, and I want to calculate, and you have to page down. So previously we've done linear regression, quadratic regression, cubic regression. Keep on going. LN regression is for a logarithm. We want option 0 for exponential regression. I'm going to select that. Okay, and now this calculator, I have to tell it where to look for my x's and y's. The default is it will look for x in the L1, y in the L2, and that's where I've put this information. But if you have it somewhere else, you need to put parentheses and then give it like a coordinate of points. So mine's in L1, comma, L2. If you have the other type, all you have to do is page down to where it says calculate, make sure your x's and y's are in the right spot, change those if you need to, and then I'm going to hit enter. Okay, now the form is a times b to the x power. And here's my a and my b values. Okay, so I want to round to 3 decimal places. So it looks like that's going to be, let's see, this is giving me weight. So weight equals 100.3728 would round to 3. And then my b value is 0.877 for my 3 decimal places to the, I'm going to say t for time in weeks. Okay, now part B is use this model to predict how much remains after 9 weeks. Okay, so all we have to do is plug in 9. 100.373, 0.877 to the 9th. Okay. And then we've got 0.877 to the 9th power. And I'm getting about 30 point, they rounded theirs to 1 decimal place, so I'll round mine to 1 decimal place, and that's in grams. Okay, now for the next part, use the model to estimate the half-life. Okay, so use the model. So that means I'm going to come to this formula. 100.373.877 to the t equals half-life is the time for half of my start to remain. If I'm using my model, I've got to assume this is my start. So I need half of that. Now you could type that out if you want to. You end up with 50.1865. But look what happens at the next step. You have to isolate your exponential, which means we're going to divide by the 100.373. And of course, we're going to end up with a half here because we just found that other value by saying it was half of what we had. So you could cut right to this where you have the exponential with no number in front equal to a half for your half-life. Okay, now we need to find a value of t. It's an exponential equation, so I'm going to use logs. The natural log of a half equals the natural log of 0.877 to the t, the decimal in there. Now log properties, that exponent t comes out in front. Let me make that 0.877 so it's a little clearer to see. And just now divide. T is the natural log of a half divided by the natural log of 0.877. So natural log of a half divided by natural log of 0.877. And I'm getting about 5.28. And this is in terms of weeks, so 5.28 weeks. Now let's look at the data and see if that matches up. So here we started with 100, so half-life would be when 50 is left. At the end of 5 weeks it was 51.8, at the end of 6 weeks it's 45.5, so it should be somewhere in between 5 and 6, closer to 5 than it is to 6, so our 5.28 certainly makes sense.